Hello, this is the Senior Design Project Summary video for Team 14 of the UCF Senior Design Spring 2022 class. We were tasked with programming the RE-RASSOR Arm to have both manual and autonomous functionality. In collaboration with the RE-RASSOR CART team, our main goal and the intention behind our project was to help the Florida Space Institute develop a model rover based upon their original NASA design. It would be affordable to educational clubs and institutions for recreation, as to spur the intellectual curiosity of today's youth and inspire them to consider pursuing a career in robotics. The project was split into two main components, software and hardware. The project was intended to use the newly made robotic operating system, aptly named ROS2. We needed to update all the ARM code to work with this new system, and through the process, updated all the code that worked with the simulation system Gazebo. The mobile app was given a UI upgrade, and the foundational work for Move It used in conjunction with the ARM software was laid. For the hardware, we worked with both a Raspberry Pi and a Jetson Nano. The former has undergone severe price inflation due to chip shortages, and the latter has become end of life, which would lead to issues down the road. The computer of choice would then send the commands to the Arduino using the Arduino IDE. The Arduino would send that data to the ramps board, then to the stepper motors. The ramps board and the stepper motors are both well-known tools in the 3D printing community, and they worked as cheap but practical hardware for our purposes. The plastic that made up most of the arm was all 3D printed as well, with some of the cheaper PLA components such as the gearboxes and gears being replaced by tougher polycarbonate parts. The arm has 5 joints. The first allows it to move 360 degrees along its base. From there, 3 joints allow the arm to move up and down, forward and back from the base. Finally, there is a joint that moves the grabber component 360 degrees. We, however, never used this motor, as the arm was unable to lift itself when attached, and the grabber component has not been fully designed and implemented. The arm is planned for use in constructing landing pads, roads, and whatever else can be induced using the tiles made of regolith or moon dust. Therefore, the grabber component is critical to the use of the arm. Current design adjustments are still in consideration for this to happen, but until then, it was not deemed necessary for us to get the arm moving like we wanted it to. The project started on poor ground, as the ARM code had been left behind the cart when a previous senior design team had failed to update the ARM code to ROS2. This meant our code needed to be updated to ROS2 before we could even begin programming the ARM. Fortunately, our project manager discovered this flaw, and it was rectified, taking the entirety of the summer to accomplish. Once we had that solved, we also needed to fix the mobile app code. The mobile app did not properly communicate with the server, which was another issue that had been solved before the project finished its research phase. Once the ARM code was able to be properly built upon, we found that ROS2 Foxy, the version of ROS2 the ARM code we inherited was using, did not have a Move It setup assistant. Move It is a highly regarded library used for motion planning, which would be crucial for having the ARM utilize robot vision. There was little documentation regarding ROS2 Move It, and the tedious process took far too much time for us to actually implement robot vision on the robot itself. However, the simulated arm is capable of using Move It, which means future teams will only need to bridge the gap of physical implementation instead of concerning themselves with these configuration issues. The next issue came from the Intel RealSense camera, which was the hardware we were planning on using at the time. ROS2 requires we use Ubuntu 20.04, while the Intel camera required we used Ubuntu 18.04. To get around this, we set up a Docker container that used ROS2 Foxy with an Ubuntu 18.04, which means future teams will have access to the Intel RealSense SDK, as well as ROS2. Considering the problems of the cart tipping over if the arm was mounted on its front, we decided to put the arm in the middle of the top of the rover to give it the best balance available. Another design choice considered making a hierarchy of robots, with a mothership that wields the arms and uses the carts for gathering regolith to bring back to the ship to be made into tiles, similar to drones. When it comes to autonomous functionality, it may be better to use servo motors instead of stepper motors, but the stepper motors are fine for manual movement. Even though servo motors are more expensive, their feedback system is almost integral to Move It as a program. These suggestions, however, are completely up to future teams to decide upon. As it currently stands, our work with the project is done, and we hope future teams will be able to build upon what we have completed. We would like to thank the Florida Space Institute and the University of Central Florida for this opportunity to grow as computer scientists, and as new members of the workforce.
So one of the challenges we faced at the beginning of this project when we were in the planning stage was figuring out what to do with the hardware. Since we had only ever dealt with software during our education here at UCF, it was definitely a challenge figuring out how we would actually implement software on hardware. So to overcome this, we started with what we knew, software.
We actually didn't really have an idea of what the project actually needed from a resource standpoint. We didn't know what it meant to be a part of the software team or the hardware team, what that involved. And because of that, we couldn't really divide it up equally as it actually ended up being, though it ultimately ended up just being everybody did what needed to be done to complete the project.
A challenge our team faced during planning was that the software wasn't actually converted to the version we needed to use. We overcame that by starting to work earlier than we needed to, as well as over the summer, so that once we began our Senior Design 2 semester, we had all the software converted.
What motivated me to stay focused on the project was just the fact that the rest of the team was super focused and motivated on it. The fact that they kept saying hey, at this time we're gonna do this, and everything like that just allowed me to stay focused and stay concentrated on completing this project.
The biggest motivation for me for this project was the project itself. As soon as I heard about the project during my senior design class, I was pretty excited about it because it was something related to space, and it was something new that I haven't done before, and it opened the opportunity for me to learn new things, and that was the main reason I was so motivated throughout the semester with the project.
He gave us a lot of pointers on what to do with stepper motors and other things like that, and so we just took his advice to heart, since we know that he was the expert on all the hardware stuff, and we trusted it and put it through.
As we are computer science students, we processed stakeholder feedback usually by taking most of it to heart, as he was more on the electrical side. By having the hardware here, we took most of his feedback and applied it directly to the project so that we can continue to work on the software. With the feedback that we had from our sponsor, we usually communicated that with our group and other groups so that we knew that the changes we were making to the project were going to progress the project further.
We ended up most of the time using his feedback to take apart the arm, replace different parts, use something to change current voltage, or it was a lot of figuring out how to do the hardware part, and that was where his help came in.
Whenever he would tell us to just turn a screw on the stepper motor to change the voltage or something, we would do exactly that.
All the different tools and things that can go into a project, such as this one where there are a bunch of different operating systems that I didn't even know existed. And another thing is robotics in general. Before this, I hadn't even known how to do anything related to robotics, but now that I've done this project, I think I will be able to bring that to the table in a future job if that's something they offer, and it also allows me to try doing different things rather than being stuck on one software project. I can move to a bunch of different ones.
The biggest lesson I learned throughout this project was how important it is to have communication between teammates, as it is really important to have communication. It makes sure that the project is going well, as well as each member knows about what's being updated or being changed, or what's being made in the project. And this was a really important part about our team, as we weren't familiar with each other in the beginning, and throughout the semester we got really used to each other, as well as started spending more time working together. Eventually it led to us being good friends, as well as our project being such a success as it is.
I chose to be on the hardware team because I felt like it would be a good challenge for me. I didn't have a lot of hardware knowledge, and I felt like I should broaden my horizons and figure out what a Jetson Nano is, what a Raspberry Pi is, all that sort of stuff. And so I thought it was a very nice challenge.
My motivation for working on the hardware side of this project was getting to see a new side of projects. I had always worked on software before, and so getting to work on hardware was definitely a new experience, and getting to bridge the gap between software and hardware was a really cool experience.
The motivation behind me choosing my particular topic was that we needed to convert the software before we got to work on the hardware. So by me focusing on the software, I knew earlier in the project, I knew that we were able to try to progress the project as fast as we could so that we can begin working with the physical arm itself.